Okay, today we're going to talk about molecular compounds. But before we do that, let's recap on ionic compounds. We've already discussed these. And ionic compounds come from ionic bonds, remember that? So to have an ionic bond, we need a metal and we'll need a non-metal. And then our metal is going to be a cation, meaning it's going to have a positive charge, and our non-metal is going to be the anion, which is a negative charge. Because in all ionic compounds you have to have a metal and a non-metal. So in my example here, if you can see that, we have aluminum and sulfur, okay? So we're going to make these bond. To do that, and we'll show you here in a minute why we need all these, but we need 3 sulfur and 2 aluminum. Now what's going to happen in our ionic bond, aluminum is going to give up its electrons and give them to sulfur. That's what makes him positive. He's getting rid of negative electrons. That will make him positive, and he'll like that because he'll have a electron configuration like a noble gas. Sulfur will be happy because he'll have an electron configuration like a noble gas, because everyone wants to be like a noble gas, because noble gases have 8 valence electrons, and we've already discussed all this. But we're going to review this. So here's what happens. Aluminum's 3 electrons are going to go over here to sulfur, and this one's going to go to sulfur. So now this sulfur will have 8, and then this electron is going to travel down to this sulfur, and then this aluminum's electron is going to go over here to sulfur, and then these 2 will go to the last sulfur. We'll fill these in. So now sulfur has 1, 2, 3, 4, 8 here, 8 here, 8 here. So he has 8. Each of these sulfurs have 8 valence electrons, and so that makes them happy. I don't know if you can see that. So they're happy. The aluminum, they got rid of 3, and that makes them, so we can look at our periodic table here. Aluminum is right there. We count back 3, 1, 2, 3, and it goes back to being like neon. Because neon, let me get this all on the screen here. Okay, here's aluminum. 1, he lost 1, 2, 3, and he's like neon. So, he technically has we're not going to draw him in, but he lost his valence electrons, and now his new valence is 8 valence electrons. So that's a lot of information, but that's a review. We've already gone over that. So let's skip on over here back to what we've learned. So we're still on ionic compounds. We have aluminum and sulfur. Aluminum, we said, is going to lose 3 valence electrons, so he has a charge of +3. He lost 3 negative things, so that means he's +3 now. He has 3 more protons than electrons, so his charge is aluminum +3. Sulfur is gaining 2 negative things, so his charge will be a -2. Okay, so here's the simple way to show what ionic compound we're going to form. Here we have 2 aluminum pairs with 3 sulfur. We drew the lowest structures, the electron dot structures, and showed you why this is happening. Now this is the shortcut method. Here's the compound we're going to make. Aluminum, sulfur, going to come together because one's a metal, one's a non-metal, one's positive, one's negative, and we're going to crisscross the charges. So this charge is going to become a subscript for aluminum, and this charge is going to become a subscript for sulfur. So we will have Al2, the 2 came from the charge on sulfur. This is not a charge, this is telling us we need 2 aluminum, and then the charge on our aluminum will be the subscript for sulfur. So we need, to make this ionic compound, we need 2 aluminum for every 3 sulfur. That's what this says. And you can simply come up with that by knowing the charge on aluminum, knowing what charge sulfur likes, taking the values of the charges and crisscrossing them to get the ionic formula, which is Al2S3, aluminum sulfide. Aluminum, and then sulfur is the anion, so it becomes sulfide. And I know this is a lot of information, but we already covered this. This is like a little review to bring us to. Wait, we're gonna wait for a second. Molecular compounds. We're gonna talk about molecular compounds today. Before we do that, I want to talk about one other thing. Before we do that, we have monatomic single atoms. We have monatomic meaning single atoms. There's atoms that like to be monatomic. They don't like to bond. And that is back to our nobility, our noble gases, group 8A. So look at our periodic table. This group over here, helium, neon, argon, krypton, xenon, and radon, all noble gases. They have, and why they don't bond, and why they don't bond, they have, you guessed it, hopefully you did, 8 valence electrons. They're happy with their electrons. They don't want any more, they don't want any less, they're happy, so they don't have to bond with anyone. Remember, we bond to get 8 valence electrons. Noble gases already have it, so they're not going to bond. That means they are monatomic single atoms. Okay. Now let's talk about the other type of compounds. These guys have to bond. Molecular compounds. Molecular compounds come from covalent bonds. So it's just like an ionic bond forms an ionic compound. Covalent bonds will give us molecular compounds. So, what is a covalent bond? Put this back up here. The whole thing in here. Covalent bonds are when atoms share electrons. So, we're going to show with our first example here, methane. So we have a carbon, and then we have hydrogen all around him. The green dots are hydrogen's electrons. The black dots are carbon's electrons. Carbon, if you look on the periodic table, has, count from the left here, 1, 2, 3, 4 valence electrons, because he's in group 4A, so he has 4 valence electrons right there. And then hydrogen is in group, or he's 1 over, he's in group 1A, so he has 1 valence electron. Alright, so back to this. Hydrogen wants 2 valence electrons to be like the noble gas helium. Carbon wants 8 to be like the noble gas neon. So if carbon can get 4 hydrogens around him, he can do that. And if hydrogen can get near just 1 carbon's electrons, he can get his valence electrons. So what hydrogen does is it says, hey, I'll share 1 if you share 1 with me, and then I can count these 2 as my valence. This hydrogen does the same thing. He says, I'll count those 2 as my valence electrons. I put in 1, you put in 1 carbon, and now we're happy. This hydrogen does the same, and this hydrogen does the same. So, they all are counting that they have 2 valence electrons, meaning they're like helium. Carbon says, okay, you all share with me, and I'll share with all of you, and so I'm going to count your, and yours, and yours, and yours, and now I have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So now I'm happy because I'm like neon. I have 8 valence electrons. I'm a noble gas. And so that is covalent bonding. They are sharing these electrons. No one's giving anything away. They're sharing these electrons. They're both pulling on them because they all want these electrons. So that's a covalent bond. That's one example. Another example that you're very familiar with is water. Water's going to be black here. And I'm going to put in his valence electrons. Let's look at the periodic table real quick. He's in group 1, 2, 3, 4, 5, 6. He's in group 6A. And so that means he has 6 valence electrons. So I'm going to write these in. So I'm going to put 2 pairs on the top and 2 pairs on the bottom. And then I'm going to put 1 on the left and 1 on the right. Now hydrogen has 1, we just said. Hydrogen has 1, and I'm going to stick his over here near oxygen. So here's what happens. Hydrogen again says, I'll put 1 in, if you put 1 in, oxygen, and we'll share. And now I have 2, and I'm like helium. This hydrogen that says the same thing. Hey, you put 1 in, I'll put 1 in, we'll share it, we'll both pull on them, and I can count them. So hydrogens are happy. Then oxygen says, okay, I'm sharing mine, you're sharing yours. So that gives me a total of 1, 2, 3, 4, 5, 6, 7, 8. So oxygen is happy. And then we